So question 6 says to rewrite this expression without parentheses and simplify. And I made sport of more than a few of you walking around to your groups. Because what did many of you do in number 6 that I later told you was not a good idea? What was your first instinct?
Square.
Yeah, the first instinct that many, many, many people have. So if you did this, you were in very good company in losing credit on problems like these. The instinct is just that the distributive property should get us through this, right? Because it works in so many other contexts in algebra. The gut reaction is just to, in order to square w plus 5, square w and square 5. W squared plus 25. Maybe I'll say plus 5 squared. Just put that intermediate step in there. Okay. And I know every time I teach algebra, regardless of the level, but usually a course like this one or a course like Math 090, I put questions like these on every exam. And we talk about them every time after the exam when half the class does this, and I take them behind the woodshed for it on the exam. And then next time I give the same question on the exam, they do it again. So if there's one thing that I want people to get out of this discussion, it's that distributive properties do not exist for every pair of operations that we would like them to. Not everything distributes over everything. The reason that this is so problematic is because the other distributive properties are so useful. Let me put our little hierarchy of arithmetic up here on the board again. This little layer cake that shows the different operations in arithmetic and how they relate to one another, right? Addition is the most basic, and multiplication is built out of a repeated process of addition, and repeated process of multiplication gives us powers, right? So that's going up the left side of this table. So operations that are adjacent on this list, above one another, in other words, do distribute. So multiplication distributes over addition, for exactly the reason that it is built out of addition. So, for example, in a problem like 6, or maybe I'll write it this way, 2 times the quantity x plus 6. That's totally fine to distribute because it's multiplication on the outside and addition on the inside. Yeah, that's fine. Likewise, and this is another one of the properties of exponents that you reckoned with in this module, the adjacent operations that are one step higher on this hierarchy also distribute because of the nature of their relationship, right? Exponents distribute over multiplication. Distributes. So, for example, if I had a problem that looked like 6x quantity squared, we can distribute. That's totally fine. Why? Because it's a power on the outside, and it's multiplication on the inside, and that's a green light to distribute the power to each of the factors. And we're totally good. But neither of those are what we have in question 6. In question 6, what we have is a power on the outside and addition on the inside. And that is the recipe for disaster. Those two operations are not, in fact, adjacent. They're too far apart. So there is no distributive property that links an exponent on the outside with addition or subtraction on the inside. And it's pretty simple, straightforward, I guess, to demonstrate why this is not, in fact, correct. One of the ways to convince yourself that this distribution doesn't actually work is to try plugging a number in there for w. What happens if we pick, I don't know, w equals 1? Then what is w plus 5 squared going to equal? If w is equal to 1. Yeah, but I want to use this specific value for w for a minute. Right, so this is going to be 1 plus 5 squared, and using the order of operations, we're going to add the 1 and the 5 first, because it's inside the parentheses. And what's 6 squared? 36. On the other hand, what's w squared plus 25 if w is equal to 1? Yeah, 1 squared plus 25. 1 squared is 1. And 1 plus 25 is 26. So why does this short example kind of give the lie to the simplifying that you actually want to do here? What is this illustrating? If it were really okay to simplify w plus 5 squared into w squared plus 25, what would you expect to happen if we plug the same w into both of those expressions? In this process of what we now find is incorrect simplification, we have taken an expression which, let's say w were equal to 1, an expression which had the value 36, and by this process of incorrect steps, turned it into something which no longer has a value of 36. When you simplify an expression, what you get at the end has to have the same value as what you started with at the beginning, regardless of what w is, or regardless of what x is, or whatever the variable is, right? What you end with has to be equivalent to what you started with. And clearly, that's not the case for this proposed simplification. If this were correct, if it were correct that w plus 5 squared is equal to w squared plus 25, then the number that we get when we evaluate each of those expressions for the same value of w had better be exactly the same. The fact that 36 and 26 are not the same shows us that this can't be right, because these are not equal. That means that these expressions are not equivalent to one another, which means we did something wrong if we try to simplify w plus 5 squared to be w squared plus 25. So enough about what not to do. What should you do instead? What's your way around this? How are you going to avoid this mistake, which is sometimes called in my circles the freshman binomial theorem? Yeah.
Since the whole expression is squared, you would just write the expression 2 times and then distribute from there?
Yeah. Right. So the key, and this is why I kind of like how this question is phrased, is the phrasing of the question itself kind of gives you the way forward. Instead of going straight ahead at this and trying to simplify it without thinking, which is what's happening when you're trying the distributive property, it tells you to first rewrite this expression without parentheses. It gets you to think, what does it mean to square something? Well, what does it mean to square w plus 5?
Number times itself.
Yeah, it means to multiply it by itself. So w plus 5 squared is the same as w plus 5 times w plus 5. That's the step that people miss. Because chances are, if you got there, then from here you knew what to do. Because now this problem looks an awful lot like the simpler problems that came before it. Because once we get here, what's the strategy?
FOIL.
Yeah, FOIL. Right? Because we sort of recognize the form here. It's a binomial times another binomial. Which means, and I'm going to use our little lattice again to keep track of this multiplication. That what we end up multiplying is w plus 5 times w plus 5. We end up getting 4 terms, w times w, 5 times w, another 5 times w, and 5 times 5. And then adding all those results together to get w squared plus 5w plus 5w. What do we get? How many w's do we get in total? Yeah, 5 plus 5 of them. And then plus 25 at the end. So notice we get 2 of the same terms that we got when we did it the incorrect way. We get the w squared and we get the 25. They're still a part of the correct answer. But what the naive approach misses is it misses that middle term. It misses that cross term where we multiply a 5 by a w and then a w by a 5. Right? So that's the part that ends up missing if you incorrectly distribute the power across the w plus 5. So on our exams in this course, because this is a safe space for us, the instructions on such a problem will say what they say up here. Rewrite without parentheses and simplify. But even after you leave the confines of this course and go on to pre-calculus, when you're squaring something or when you're raising anything to a power, if that thing has multiple terms in it, be thinking, rewrite this without parentheses. Don't go straight ahead. Rewrite it as a multiplication problem. Because once it's a multiplication problem, you know what to do with it. FOIL it, right? And that is the right way forward. And you can check, for instance, that if w is equal to 1, that my first expression is going to equal 36, as we were saying before. But now our second expression that we get here at the end, 1 squared plus 10 times 1 plus 25, now also equals 36, because it has that missing 10 that we didn't have before.